Okay, so LT4. Okay, we want to try to write 2, 3, 4 as a linear combination of these other three vectors. So I would like to write y equals, oh, what do I call these numbers? A, B, and C, I guess. So AU plus BV plus CP. All right, now let's expand this, though, by components. Okay, so the components of y are 2, 3, 4. And I would like that to be A times, let's see, 1, 1, 0 plus B times 0, 1, 1. Oh, sorry, 1. Almost blew that. And this C times negative 1, 0, 1. Okay. Okay, so what would this mean? Well, if this were going to be true, then each individual component would have to add up the same, right? So I would need for 2 to equal to A minus C, right? And let's see, I would also need, looking at the center component, I would need 3 to equal to A plus B. And I would need for 4 to equal to B plus C. So what we've got here is 3 equations and 3 unknowns, and the general process here is you want to eliminate a variable, reduce it to 2 by 2, etc. You can play that game. I'm kind of hoping that we can get lucky here, because let's see here. Yeah, we can get pretty lucky here, because these things on the right-hand side are sort of simple, relatively simple. So, for example, notice that if I take this, and there's several different variations of what I'm about to show you that would work equally well. I'm going to subtract this one minus that one. So I get 3 minus 4 equals, and then I have A plus B minus B plus C, and that gives me A minus C. And of course that's negative 1. So A minus C would have to equal to negative 1, but it can't because it also has to equal to 2. So therefore there's no way that this could possibly work. So there's no solution. That means that this is not possible. So this vector is not a linear combination of those two,
so
those three.
Able to come up with the A minus C because that's the only way you can get those with those 3 vectors, since you have the zeros.
Say that one more time, I'm sorry.
So you did A minus C equals 2, and you said that's true because that's the only way you can possibly get
Well, no, I got A minus C was equal to 2 because I looked at this vector equation that I want to work, right? And I just looked at the first component. So 2 is equal to A times 1 plus B times 0 plus C times negative 1, and that just ends up being this. So if this vector equation is going to be true, then that, individually these 3 component equations that I get from looking at one component at a time have to also be true.
Maybe if B also had a number in the X spot.
Yeah, if this was like a 5 there, then this would be plus 5B. Yeah, so the fact that there was a 0 there and there and there is what made these look kind of pretty. Yeah. So this was, convenient. By the way, Math 107, we're going to be looking at systems of equations a lot like this and I'll be showing you a more sophisticated and sort of bulletproof way to do this kind of thing. Yeah. Okay. Yeah.
Question on the test, is it all the way up through what we learned today? It's like 4.5 whatever, or is it?
No. Just through 3.1. So I sent an email about that. Yeah, and
does that include 3.1?
It does include 3.1, but not 3.2.
Gotcha.
Right. Yeah. Okay. Oh, I better stop this.